student, welcome to chemistry class of grade 11. In this video, we will discuss about how to measure the enthalpy change. As we know that we have three techniques to measure the enthalpy change. First, we can measure by experiments. Second, we can measure based on Hess law, and then third, we can measure by the data of bond energies. Now, how to measure the enthalpy change based on Hess law? Let's check this video.
Hess law. Conserving energy. The law of conservation of energy states that energy cannot be created or destroyed. This is called the first law of thermodynamics. This law also applies to chemical reactions. The total energy of the chemicals and their surrounding must remain constant. In 1840, German Hess applied the law of conservation of energy to the enthalpy change. Hess law states that the total enthalpy change in chemical reaction is independent of the route by which the chemical reaction takes place as long as the initial and final conditions are the same. Enthalpy cycle. We can illustrate Hess law by drawing enthalpy cycle, or we call it Hess cycle. In this figure shows that the reactants A plus B combine directly to form C. This is the direct route. Two indirect routes are also shown. One of the way of changing A plus B to C is to convert A plus B to different substance F plus G, intermediate, which then combine to form C. We can use Hess law to calculate enthalpy change that cannot be found by experiments using calorimetry. For example, the enthalpy change of formation of propane cannot be found by direct experiment because hydrogen does not react with carbon under standard condition. Measuring the enthalpy change based on Hess law. First, we use the enthalpy change of formation of the reactants and products to calculate the enthalpy change of the reaction. We take note of the direction of the arrow to find the one stage or direct and two stage or indirect route. When we use Hess law, we see that delta H2 equal to delta H1 plus delta HR. So, delta HR is delta H2 minus delta H1. For general formula, we can write delta HR is delta H formation of products minus delta H formation of reactants. To calculate the enthalpy change of reaction using this type of enthalpy cycle, we use the following procedure. First, write the balance equation at the top. Second, draw the cycle with elements at the bottom. Third, draw in all arrows. Make sure they go in the correct directions. Fourth, apply Hess law, taking into account the number of mole of each reactant and product. If there are 2 moles of a product, for example 2 CO2, we must multiply the enthalpy change of formation by 2. Also remember that the standard enthalpy change of the formation of an element in its standard state is 0. Work example. Calculate the standard enthalpy change of reaction as follows. If the relevant enthalpy change of formation are as follows. First, we have to write down the equation, and after that we write down the elements of the reactants and the product. Number 3, we apply. This is the one root, this is the direct root, and this is the indirect root. So we can apply Hess law as follows. Delta H2 equal to delta H1 plus delta HR. Or we can find the value of delta HR is delta H2 plus minus delta H1. Delta H2 is delta for H formation of natrium carbonate, delta H formation of carbon dioxide, and delta H formation of water. So we can count it all in one side, and then minus to delta H1. Delta H1 is delta H formation of natrium hydrocarbonate. And then we calculate, and this is the last result. Delta H2 is forming of product, and delta H1 is forming of reactants. Note, the value of delta F standard of natrium hydrocarbonate is multiplied by 2 because 2 mole of natrium hydrocarbonate appear in the equation. The value for delta F standard for natrium carbonate, for carbon dioxide, and for water are added together to give delta H2. Take care to account for the fact that some values may be positive and some negative. Second, we can measure delta H by the enthalpy profile diagram. So this is the enthalpy profile diagram, the enthalpy formation of CO2. So first we have to determine the direct route. So this is the initial state, and this one is the final state, and this is the direct route, and this is the indirect route. We can apply Hess law as follows. Delta H1 equal to delta H2 plus delta H3. So we can find the value of delta H3 is delta H1 minus delta H2. So we can put the value of each delta H, and then we can find the answer. Third, calculate the enthalpy change by reaction data. Given the following data. First reaction is the formation of fluoric acid, and second reaction is the formation reaction of tetrafluorocarbon, and the last reaction is the formation of ethene. Determine the enthalpy change of the reaction below. So first thing that we can do is step 1, write down the reaction for which you want to find the enthalpy change, or we call it the final reaction. So first you have to write the final reaction. And second, write down the reaction data according to the final reaction. You also can reverse the reaction according to the final reaction. For example, this reaction, ethane as a product. So because this reaction needs ethane as a reactant, so we have to reverse the reaction, become these reactions. Because the reaction is reversed, so we have to change the value. This value is positive. After reserve the reaction, it becomes negative. Take care to the mole of each substance must be adjusted with the mole of the final reaction. The final reaction CF4 is 2 mole. And the data of CS4 is 1 mole. So we have to multiply CF4 by 2. The final reaction HF is 4 mole. The data of HF is 2 mole. So we have to multiply by 2 of this reaction. So it has the same mole. Eliminate the same compound with the same mole on different sides. There are the same compound, the same elements, that is C and C in different sides. And there are elements that is hydrogen, 2 hydrogen in different sides. So we can eliminate this element. And add up all the value of each reaction. Take care to the value. It could be positive or negative. And this is the value. This is my reference list. Thank you.